Bismillahirrahmanirrahim. Dear students, Assalamu alaikum. Today we are going to start Unit 4. The title of Unit 4 is Algebraic Expressions and Algebraic Formulas. From the title of this chapter, it is clear that we have to manipulate formulas to solve exercise. It means you have to remember formulas and the techniques how we can solve questions using these formulas. So let's start the lecture. Algebraic expression. How we can define an algebraic expression? When operations of addition and subtraction are applied to algebraic terms, we obtain an algebraic expression. For example, so here I am writing this is 3x square. This is algebraic term. I write 3x cube. This is another algebraic term. 4x5. This is another algebraic term. So these are the algebraic terms. When we apply the algebraic operation on these terms, we find an algebraic expression. Just like here, 5x square minus 3x. This is algebraic term. This is another algebraic term, and this is another. When we insert these operations, minus, plus, so this become an algebraic expression. So this is another algebraic expression. Polynomials. A polynomial in the variable x is an algebraic expression of the form p of x is equal to an x raised to power n plus an minus 1 x raised to power n minus 1 plus an minus 2 x raised to power n minus 2 plus up to so on plus a1x plus a naught. The condition on that, an is not equal to 0. N is a non-negative integer. The important condition for the polynomial, for an algebraic expression become a polynomial, so that these powers should be non-negative integers. These powers should be non-negative integers. This power can be 0, 1, 2, 3 up to so on. These can be integers. Another thing is that this is a polynomial of degree n, since here an is not 0. So what is the degree of the polynomial? The degree of polynomial is the highest power of the variable. So here is variable is x, so highest power is n. So n is the degree of this polynomial. So you have to remember that in a polynomial, the highest power of the variable is known as a degree of a polynomial. So here, and these terms an minus 1, an minus 2 up to so on, a1, a naught, these are coefficients of terms. 3x square plus 8x plus 5. So this is a polynomial. Why this is a polynomial? Because here this is power 2, this is power 1, and so the throughout the in this expression the power is an integer, non-negative integer. So this is a polynomial. So highest power is 2. So this is a polynomial of a degree 2. Now here is another example. So here x cube, x square, x1. So here you can say that this is x raised to power 0. So this is another example of a polynomial, and this is polynomial of a degree 3. Now here, so here this is not a polynomial. Why this is not a polynomial? Because here x raised to power 1 by 2. Square root mean this is x raised to power 1 by 2, and 1 by 2 is not an integer. So this is not a polynomial. Next concept is rational expression. The quotient p of x over q of x of two polynomials, p of x and q of x, where q of x is non-zero polynomial, mean q of x not equal to 0, is called a rational expression. This is polynomial if numerator is polynomial, denominator is polynomial, then we say that this is a rational expression. And you have to remember that every polynomial is a rational expression. Every polynomial is a rational expression, but every rational expression need not be a polynomial. For example, I write this is a polynomial of degree 2. This is 3x plus 3. So this is a polynomial of degree 2. If we write this, here is 1. So q of x is equal to 1. So this polynomial is also a rational expression. But in this form, when we have a rational expression, this need not to be a polynomial. So you have to remember that a polynomial is a rational expression, but rational expression is not a polynomial. Another thing here, that every polynomial is a algebraic expression, but every algebraic expression need not to be a polynomial. So let's start the exercise 4.1. Question number 1. Identify whether the following algebraic expressions are polynomials. Yes or not? Here, this is 3x square plus 1 by x minus 5. So this can be written as 3x square plus x raised to power minus 1 minus 5. So here this is non-negative. So this is not a non-negative integer. So we can say that this is not a polynomial. So simply this is algebraic expression. So we can say that this is a algebraic expression. Part 2. Here this is 3, 2. Now 1 and 1 by 2. 3 by 2. X raised to power 3 by 2. So this is not a polynomial. Why? 3 by 2 is not a integer. So this is only an algebraic expression. So here x square minus 3x plus square root of 2. X square, x raised to power 1. So variable's power is integer. So this is a polynomial. Here part 4. So 3x divided by this. So this is a algebraic expression. We cannot say that this is a polynomial because this is in form of quotient, and after simplification, and this will be a rational expression, and rational expression may not be a polynomial. So the only polynomial is here is part 3. Question number 2. State whether each of the following expression is a rational expression or not. Here this is not polynomial, this is not a polynomial. Why this is not polynomial? This is in form of p by q, but this p of x is not a polynomial because x raised to power 1 by 2. 1 by 2 is not an integer. So this is not a rational expression. Here this is a polynomial of degree 3, this is a polynomial of degree 2, this is a rational expression. Here this is also a polynomial of degree 2, this is also a polynomial of a degree 2, this is a rational expression. Now here this is not a polynomial. Why? This x raised to power 1 by 2. So variable with power which is not an integer, non-negative integer. So this is not a rational expression. Question number 3. Reduce the following rational expressions to the lowest form. So now we have to simplify these questions. We can here just we have to simplify these. This 30 cancel out with this, with 34 times 120. Here power y cube, here is y1. So we shift this term to here because this power is more powerful, this is greater power. So 3 is greater than 1, so that's why we shifting one power to upper side. Here z is power 5 and here z is power 2. So this power is less than this, so we'll shift this into numerator. Here x3, this power is greater than x square, so we shift x square to denominator. So y cube, this will be y minus 1, z5, this will be z minus 2, x cube, y minus 2, and these bases are equal. We add these powers, and after simplification we have this. So before starting the part 2, we must know the formulas. So first formula is that a square minus b square is equal to a plus b and a minus b. We use this formula. Second one, we can write a cube plus b cube, this must be equal to a plus b, a square minus ab plus b square. The second formula. Third, we will use in this lecture a plus b whole square is equal to a square plus 2ab plus b square. Fourth, a minus b whole square is equal to a square minus 2ab plus b square. So this formula you have to remember. So see here, this 2 cancel out with 8, 2 4 times 8, a as it is x minus 1, x square minus 1 can be written as 1 square. So we'll use this formula, a square minus b square, first formula. This can be written as a plus b, a minus b. Here a is x and b, a is x and b is 1. So x plus 1, x minus 1. So this x minus 1 cancel out with this. So we have left with 4a divided by x plus 1. Part 4, we have to simplify this. X cube minus y cube, x square minus 2xy plus y square, x minus y, x square plus xy plus y square. So here one thing is clear, that from here a square minus 2ab plus b square, if we replace x with a with x and y with b, we have this term. So this term can be written as x minus y whole square. So now x cube minus y cube. So this formula, so here a cube plus b cube is equal to a plus b, a square minus ab plus b square. Here we have to replace a with x and b with y. So a cube, x cube minus y cube can be written as x minus y, x square plus xy plus y square. So after, so we can cancel this with this. These are the same terms. So after simplification, we have left with this x minus y whole square. Sixth part, x square minus 4x plus 4, 2x square minus 8. So we have to write this in term of formula. So 4 can be written as 2 square. 4 can be written as 2 square. So first is here x square, second is 2 square, their term is 2, this term is x, and here is b is 2. So we can write this term as here x square minus 2x and second 2 plus this square. So this can be written as x minus 2 whole square. So taking 2 as a common, x square minus 4. So 4 can be written as 2 square, a square minus b square. So x minus 2 whole square can be written as x minus 2, x minus 2, or 1 1, just separating. X square minus 2 square, x plus 2, x minus 2. So we can cancel this with this. So we left with x minus 2 over 2x, 2 into x plus 2. So this is question number 3, how we can solve the questions using formulas. So you have to remember these formulas. If you have remembered these formulas, you can easily manipulate these formulas to solve this exercise. So Allah Hafiz.